video today is going to be going over Unit 2 and Unit 6 and 5. So there were some of these questions on the front page I went over with a lot of you guys, but I'm going to go over them again in this video so that you have that to look at. Okay, so for number 1, you need to know which angle relationships are supplementary, which means they equal 180, and which angle relationships are congruent, which means they are the same. Okay, so the ones that add up to 180 degrees are same side interior, same side exterior, linear pair, and the ones that are congruent are alternate exterior, alternate interior, vertical, and corresponding. So this question is asking which scenario below is not a possible result. That's an important word because it's basically saying which one is false, which one is not correct. So let's look at A. A pair of same side interior angles with measures of 65 degrees and 115 degrees. If they're same side interior angles, they have to add up to 180 degrees. 65 plus 115 is 180. So this is a possible result. So it's not A. B is a pair of alternate exterior angles that measure 130 and 50. Alternate exterior angles are congruent to each other. So they're the same. You can't have a pair of alternate exterior angles that are 130 and 50. This is not possible because they're congruent. So if one of them is 130 and one of them is 50, they're not going to be alternate exterior angles because they're not congruent. So that one is not possible. So that one was B. Okay? Down here for number 2, we needed to find the missing angle measurement for these triangles to see if they were similar to each other, because similar triangles have the same angle measurements. So for triangle 1, if you know that all of these angles add up to 180 degrees, and you take away 64 and 90, if you subtract that from 180, you get 26. Okay, 26 degrees. For triangle 2, you know that these have to equal 180. If you subtract the 90 and subtract the 26, you get 64. So that missing angle measurement is 64 degrees. So now you can see that these two triangles are similar because they have 26 in common, they have a 64 in common, and they have all the same angle measurements. So triangle 1 and triangle 2 are similar to each other because they have the same angle measurements. This one over here has a 16 and a 90, and I think this works out to, when you subtract it, you get 74. So that one's not similar. The angle measurements are different. Okay, number 3, which pair of angles below are corresponding angles? Corresponding angles are when you have one angle that's inside the parallel lines and another angle that's outside the parallel lines in the same spot. So like angle 2 and angle 6 are corresponding. Then angle 4 and angle 8, those are corresponding. So the only answer choice that has one inside and one outside in the same spot is D. Angle 3 and angle 7. Those are corresponding. Okay, number 4. Andrew constructed a triangle so that the measurement of angle 1 and angle 2 are congruent. So let's say these two angles down here, they're congruent. If angle 3 measured 70 degrees, what is the measurement of angle 1? So angle 1 and angle 2 are the same. So let's just, for example, say we're going to choose A, okay, 35 degrees. Let's say that one was 35 and that one was 35. Every triangle, the angles have to add up to 180. So 35 plus 35 plus 70 is 140. So that cannot be right because it doesn't add up to 180. Okay, Let's try B. 55, 55, and 70. When you add those three angles together, you get 180 degrees. So that is the correct answer choice. Okay? Okay. Next page. Which of the following transformations would not preserve size and shape? No, I'm making a video. It's okay. What? Do you have a question? However many you want me to. We're just gonna do something for. Can I? I'll come after. Okay. Okay, so this is asking which of the following would not preserve size and shape. This is another one where they're asking you to pick the one that is not correct. So which one would not preserve the size? So which one would not keep the size? So preserve means to just keep the same. The only one of these that is going to change the size and shape, well, really just the size, is a dilation. Dilation is the one that changes the size. Okay? This one you have to do 180 degree rotation. So 180 degree counterclockwise rotation is going to take you right here. Okay, somewhere like around here. I could use patty paper, but I'm trying to go a little bit quicker. So the coordinates that are in quadrant 3, everything is negative. The x is negative, the y is negative, so that has to be B. Okay? All right, number 3, most of you guys got this one in class. This is a dilation and translation. Skip 4. For number 5, these points are being reflected over the y-axis. So when you reflect something over the y-axis, the x changes signs. The x coordinate changes signs. So like the 4 and the 1 are going to change signs. So -4, -3 will become +4, -3. The x changes signs. +1 will become -1. Okay? So +4, -3 is right here, this point. And -1, -3 is this point. So the answer is B. Okay? For this one, it looks like it was from here to here, it was reflected over the x-axis. Like, this is not going to be looking very beautiful, but here we go. Reflected over the x-axis and then translated to the right. So that one's B. Okay? This one, Pythagorean theorem, you had to do a picture. So Carolyn leaves her house and walks north 6 blocks. She turns and heads east 8 blocks until she reaches Maddie's house. What is the distance between Carolyn's house and Maddie's house? So this one you're just doing Pythagorean theorem. And you do 6 squared plus 8 squared equals t squared. So that would be 36 plus 64, which is 100. And then you take the square root, and the square root of 100 is 10. So 10 blocks, 6, 8, 10. Number 2, we did that in class. Number 3, I told you how to do that one in class. So this one, number 4, this is a good question. So it says find the perimeter of a square where the diagonal is 10 centimeters. There's a couple different things you have to do here. All you know is that this is 10 and that it's a square. So these two have to be the same size, right? Because on the square, all the sides are the same length. So you can use Pythagorean theorem on this question. You would do, but you wouldn't do a squared plus b squared. It's a squared plus a squared because they're both the same size. And you know that because you know it's a square. Equals 10 squared. So here's how you do that. 1a squared plus 1a squared is 2a squared. And then 10 squared is 100. So you divide by 2. And you get a squared equals 50. Take the square root of that. And the square root of 50 is like approximately 7.1. So that's how long the legs would be. So this side 7.1, this side 7.1, this side 7.1, this side 7.1. And then for perimeter, you add all four sides together. So 7.1 4 times is going to be about 28.4. So that's B. And some of you, I was telling you to show your work on that problem. So this is what your work needs to look like. Okay. Number 5, a right triangle is in the diagram below. The area of 2 squares is shown. What is the area of the third square? So here's the area of the hypotenuse, and here's the area of the leg B, and we need to find the area of leg A. So since the area is the side length that has been squared, so we already have the area of the squares, so we can do a squared plus b squared equals c squared, but the c and the b have already been squared. So we're just going to do a squared plus 400, because we already know that that is what b squared is. Just like we already know that c squared is 841 feet. So you don't have to square the numbers. They've already been squared for you. You just need to subtract. Okay, and then you get a squared equals 441. Ooh, okay. The area of the square is 441. So that one was actually C. I think some of you guys, I gave you the right answer if you chose A, because the side length is 21 feet, but I just realized that the question is actually asking for the area, so C is the right answer. Okay? For number 6, which of the following are not right triangles? Remember, for right triangles, you make the longest side C, and then you do a squared plus b squared equals c squared, and you see if that gives you if it equals c squared. So like this, 3 squared is 9, plus 4 squared is 16, 5 squared is 25, 9 plus 16 is equal to 25. So yes, that is a right triangle. Okay, we'll just do D over here. So it's 3, 6, and the square root of 45. And calculator. The square root of 45 is 6.7, so that's the hypotenuse. So 3 squared plus 6 squared, the square root of 45 squared, and a square root and squaring cancels each other out, so that would just be 45. And then you would do 9 plus 36, and that does equal 45. So yes, that one is a right triangle. Okay. Guys, for the functions, I think we're just not gonna do that. Let's do number 3 on the back. Yeah. With the function notation, we can do this one. So this function is -3 times x plus 1. So we're going to multiply by -3 and then add 1. And we're going to do that with our domain. So those are our x values, -2, 0, and 3. And we're going to plug in and we're going to find the y values or the range. So the first number I'm going to use is -2. So I'm going to do -3 times -2, add 1. And that equals -3 times -2 is 6, plus 1 is 7. Oh, that's actually all I had to do here, because the only one with 7 is A. You can finish the table if you want. -3 times 0 plus 1 is just 1. -3 times the next x value, 3, plus 1 is -8. So that matches our range on answer choice A. Alright guys, I hope this was helpful. I know that some of you all were struggling with some of these questions, but I will hopefully be able to answer more of them in class before we take our test. So good luck, and see you tomorrow.